Hello everyone, in this video I will be talking about Latin square design and its application in the field of engineering. Latin square design, or LSD, is used to control the variation that is related to rows and columns in the field of experiment. It is a square array filled with different elements, and each elements appear exactly once in each row and each column. In here we have a 4x4 array which is filled with letters A to D. As you can see, each row and each column contain each letter exactly once. One of the advantages of using LSD is that it reduces amount of randomness, which makes comparison easier. It also allows researchers to control two variables at the same time, and each element receives treatment once. One of the disadvantages is that the number of treatments, columns, and rows must be the same. Squares smaller than 5 by 5 are not practical because of the small value of degrees of freedom for error. LSD is used in cryptography, coding theory, agronomic research, and in engineering. One of the examples in the engineering field is when 5 machines are to be tested to see whether they differ significantly in their ability to produce a manufactured part. Different materials and time of the day affects the production. Across the column are the different time of the day, and down the row are the different materials used. Each machines are assigned a random square. Different shades of blue represents the treatments, and each treatment allows us to see which variation meets the company's specifications. This is the basic ANOVA table for LSD. This shows us how to calculate the sums of squares, degree of freedom, mean of squares, and the F ratio for the following sources of variation, including the rows, columns, treatments, and errors. For degree of freedom, T represents the n in n by n square array. On the previous example that we have, it is a 5 by 5 array, and so the degree of freedom is 4. This table allows the researcher to get an idea of how the data is affected with the treatments of error.